Have you ever wondered if there could be a black hole inside our very own sun? A question that might seem far-fetched, yet it's one that taps into the most profound mysteries of the cosmos. Black holes, these invisible cosmic beasts, are the ultimate enigmas of our universe. They are unseen, yet their presence is felt, their influence undeniably vast. They are the epitome of intrigue, their existence pushing the boundaries of our understanding. Picture this, a black hole, a region of space where gravity is so strong that nothing, not even light, can escape its grasp, lurking inside the fiery furnace of our sun. It's a concept that challenges our perception of the universe, a thought experiment that stretches our imagination to its limits. This isn't just about pondering the impossible, it's about exploring the very fabric of our universe, the rules that govern it, and how they can be defied. To understand this concept, we first need to dive into what exactly a black hole is. Black holes, the enigmatic monsters of the universe, are regions of space where gravity is so strong that nothing, not even light, can escape from them. These cosmic beasts are born from the death of massive stars, in a process as fascinating as it is cataclysmic. Imagine a star so huge, so incredibly massive, that when it finally exhausts its nuclear fuel, the resulting pressure is insufficient to counteract its own gravity. The star, unable to hold itself up, collapses under its own weight. This collapse triggers a supernova, an explosion so bright that it can outshine entire galaxies briefly. But what's left behind is even more intriguing: a black hole. A black hole is characterized by two main features: the event horizon and the singularity. The event horizon is the point of no return. Once crossed, nothing can escape the black hole's gravitational pull. The singularity, on the other hand, is the core of the black hole, where all its mass is concentrated. Here, the laws of physics as we know them cease to apply, and space and time become infinitely distorted. Black holes are extreme in every sense of the word. They are so dense that if you were to somehow scoop up a teaspoon of a black hole's material, it would weigh as much as an entire mountain. They spin at nearly the speed of light, and their gravity is so strong that they literally bend the fabric of space and time around them. This extreme nature is part of what makes black holes so captivating. They represent the unknown and the unexplored. They challenge our understanding of the universe and our place in it. They're a cosmic mystery, a question posed by the universe itself, daring us to find the answer. Now that we understand black holes better, we can explore the possibility of one existing within our sun. Our sun, a constant presence in our life, is actually a star. But could it harbor a black hole within? Our sun is a colossal ball of hot, glowing gases. It's mostly composed of hydrogen and helium, with trace amounts of other elements. At its core, the sun is a nuclear furnace, where hydrogen atoms combine to form helium in a process known as nuclear fusion. This process releases an immense amount of energy, which we experience as sunlight. Now you might be wondering, could a black hole exist within this fiery inferno? Under normal circumstances, the answer is no. Black holes are remnants of massive stars that have exhausted their nuclear fuel and collapsed under their own gravity. They're incredibly dense, with gravity so strong that nothing, not even light, can escape. Our sun, although impressive, simply doesn't have the mass or the density to host a black hole. But what if we venture into the realm of theoretical physics? Enter the concept of a Hawking star. Named after physicist Stephen Hawking, these are theoretical entities where a black hole could potentially exist within a star. To achieve this, the star would have to be in a state of quantum superposition, where it's both a black hole and not a black hole at the same time. Confusing? Absolutely. Possible? Theoretically, yes. In this scenario, our sun would be a cosmic Russian nesting doll with a star, a black hole, and another star all nested within each other. But it's important to remember that this is purely theoretical. We've yet to find any evidence of Hawking stars in the observable universe. The concept of a Hawking star is indeed fascinating, but what would it mean for us if there was one inside our sun? If there were a black hole inside our sun, what would that mean for us here on Earth? Let's start by considering the sun's behavior. A black hole at the heart of our sun would likely cause significant changes in the sun's light and heat output. The intense gravitational pull of the black hole would start to consume the sun from the inside, causing it to dim and cool. Days on Earth would become less bright, and the planet would gradually become colder. This could potentially trigger a new ice age, dramatically altering life as we know it. But the impacts wouldn't stop at our atmosphere. The entire solar system would feel the effects of a solar black hole. The gravitational balance that keeps our planets in their orbits would be disturbed. planets might be drawn closer to the sun or flung out into the depths of space. The asteroid belt could be destabilized, sending asteroids careening towards the inner planets, including Earth. But what about the ultimate scenario, the black hole consuming the sun entirely? If the black hole grew large enough, it could swallow the sun whole. The result would be a solar system without a sun, a dark and cold place, with planets wandering aimlessly through space. However, this would not happen overnight but over millions, if not billions, of years. Of course, these are just theories. Our understanding of black holes and their behavior is still growing. We've never observed a black hole inside a star, let alone our sun, so we can only speculate about the exact outcomes. While the idea of a black hole within our sun is fascinating, it remains a concept of theoretical physics, but who knows what future discoveries may unveil.